All right, so to begin with, I have my vertices. So if I think about the fact that I could plot those, all right, that's over 8. Up 8 would be, up 4 from 8 would be here, and down 4 from 8 would be here. These are my vertices. So what point is halfway between those?
0.
Okay, the y value would be 0, correct. Because my center would go out 8 and stay there. Everybody agree with that? So let's make that part of the formula so far. Well, maybe we don't know that part of the formula yet. I don't know. Do we know who's more important just by plotting those 2 points? How do we know?
It's going up and down.
Yeah, it's going up and down. And look at the points. Who's changing? Y. So it's got to be something about y squared minus something about x squared that's going to be equal to 1. And so we can take this center and plug it in. Now remember, you got to plug x in with x, because that's really important. This one's backwards. Then, how far is it from the center out to the vertices? 4, and that's always A. Now they also gave me foci in this problem. The foci are down a couple more from the vertices, it looks like, because our vertices were at 4 and -4, and our foci are at -6 and +6. So that's just a couple more past the other 2, right? But how far is it from the center to that foci is very important. 6. And that's what letter? C. All right. So now that I know that, I could square that A and say this is 16. But I don't have a B to square. So that's where knowing that you can use Pythagorean theorem is important. Because if you don't have anything you can get the B from, then you've got to use this to get it. So 4 squared is 16. C squared would be 6 squared is 36. That subtracts to give 20. So what's the square root of 20 if you tree it?
Square root of 2 square root.
Correct. 4 times 5 makes 20. So it's 2 square roots of 5. Oh, that's right. We spent all that time square rooting it and we didn't need it. Tell me why. All I need is the bottom, and the bottom's always what? So a lot of times, and I did this on purpose because I wanted somebody to tell me I didn't need to do that. Thank you for noticing that. That you're wanting B squared. Why waste time treating something that you're going to go right back and square? See, if I was going to do something to this problem like graph it, for example, I'd need that, wouldn't I? Did the question say graph? So do I need to finish this graph? Just helps me get the numbers, right? So if you're given the vertices and the foci, it takes a little bit more time because you have to calculate your B squared. Not your B, but your B squared. All right, so in our next question, what's changing? The x's, because all the y's are 2. That tells me x comes first in my problem. So when you're working hyperbolas, you got to look at your points and immediately see which one is changing and tell that letter first in your formula. So if I plot over 3 up 2 and over -3 up 2 for my vertices, what would my center be? 0, 2. Everybody agree? So the x gets the 0 and the y gets the 2. How far is it from the center to the vertices? 2 or 3, y'all? 3. It's got to be how far it is to the x. So that tells me I can square that and put this under here as 9. I still don't know what to put under that one, so I keep using more. Look how much we got of the formula by just using the first piece. That's a lot, isn't it? So now let's use the second piece. 5, 2, and negative 5, 2. I don't know why I wrote 9 squared. Thank you. I was talking. When I talk and say a word, sometimes I write it. Thank you. I was talking about squaring the 3 and putting down the 9. So 3 squared is 9, but I don't know what b squared is. So now let's figure out how far it is from the center to the foci, which is 5. That's not b. That's c. So we've got to do 3 squared plus b squared equals 5 squared and figure it out. I think we know that one.
4 squared.
Right? Because it's 3, 4, 5. 25 minus 9 is 16. So it's 4 squared, so with 16, right? This is where knowing that 3, 4, 5 pattern helps, but it's not 4 that I'm putting under there because it's got to be 4 squared, right? So solving it might get there a little quicker in terms of, yeah, I recognize that pattern, but I need the squared number. So don't forget that, because sometimes people think, oh, well, 4, and they write it over there because 4 looks squared already, but I got to square it. All right, so that's what you do if you have vertices and foci. Now let's take a look at what if I have vertices and asymptotes. Well, we'll see what makes that different.
Wait, at least knows the rise over the run.
That's right. We know something about rise over run. That might be very helpful, and we'll see why that's even more helpful than foci are. But to begin with, let's focus on our points over there and see if we can figure out who's important. X, okay? X is important because X's are changing. And if I think about the fact that this is 4, negative 3, and 0, negative 3 are my vertices, what's halfway between there? Correct. 2, negative 3 would be halfway because it's 2 to go from 2 to 4, and it's 2 to go from 2 to 0. So in that case, I know that the over 2 goes with X, and down negative 3 makes this plus 3. Everybody agree? So we've got half of our formula already filled out. Now, this one's a lot easier than the other one because of the rise over run. You see, rise has to do with Y, and run has to do with X. So this has to be based on who's more important. X, right? So he's A. And this one's B. Now, it can be the other way around. If Y is more important, A would be on top. But you know what? That's not even important at all either. Because let me explain why. It don't really matter which one's A and B in this case if you don't even want to think about that. Because aren't you going to square Y and put it under Y? So even if you didn't know that the Y number is B, you still could get this problem right because you still could square this and put it under Y, and you could square this number and put it under X because you know Y's go under Y's and X's go under X's. But the reason that the run in this problem is A is because X was more important and run's about X. So it makes sense on why that would be A. But I can still do it without knowing that, right? So this problem, you almost can do the entire thing. I could have didn't need that graph, by the way. Let me remind you again what we discussed before. What's halfway between here means add them together and divide it by 2 and find the midpoint. So you don't need a graph drawn to do any of these questions technically, except for once in a while it does help a little bit to just be able to visualize if you're a real visual learner. But all of this math in these questions actually can be done without drawing the graph. It just depends on if you need that visual to see it.
Would you even need the vertices?
No, I only need the vertices to know what's halfway between those two x's.
You already got this.
No, I'm talking about if I didn't draw the graph,
Oh.
then that would be what I'd have to do. All right. So let's look at another one. This time they gave me the foci. Now that throws a big wrench into my problem.
Okay. Well, we
Yeah,
have
so
to
you
skip
said next
forward.
page.
Oh, yeah.
Yeah, we have it.
Skip.
Well, and this is a number 6, and that's not even number 6 on the right of way. It's all further along, right?
It's like it's
Okay.
That one, yeah.
All right. I doubt did that for a reason, y'all. What did they give you on 4?
It was the vertices and asymptotes.
Okay, so I don't need to do another one of those. What did they give you on 5?
Foci and asymptotes.
Okay, well, I like this one probably because maybe this one might be harder than 5. And then I picked number 6 on the next set because it had a radical in it. And I thought that might be important. So let's talk about this one. Just from what I see here in this question, I am pretty sure I don't have to calculate anything with a graph. So I'm going to go from that perspective, and I want us to see if that makes sense. Who's changing? Okay, so since these x's are changing, that tells me that x is first. Everybody with me so far? I don't need a graph to do these. If I know a lot about formulas, I can get it all without pretty much graphing it, unless there's something really strange given. All right. Don't the asymptotes have the 2 parentheses that go in this formula already? That x plus 3 is part of the center. That y minus 4 is part of the center. Everybody with me so far? All righty. I can stick a 1 under this, and that makes my rise over run. Everybody agree with that? So in this problem, the run is 1. So what's 1 squared? What's the square root of 3 squared? Okay, we're done. That's how easy it is to do one. No matter what they give you, if they give you the asymptote, the actual asymptote formula has everything you need except one thing. What was the one thing the asymptote formula didn't tell me? Who's first? It won't tell me that. It tells me A, it tells me B, it tells me the center. It won't tell me who's more important. I got to get that from these points over here. Okay? That's really important. So as long as they give me the asymptote, I got a lot of stuff given to me, which is great. So that's why I chose to go next to question number 6, which I guess might be the last one on the last page, maybe?
So the number 6 you just did was our number 6.
Yeah, I know, but keep turning. There's another number 6.
The independent practice one?
Right, an independent practice one? Right? Okay. I chose this one instead of doing another one off that page because it had this radical in it, and I wanted to talk about another one with a radical. And this one is just a bit different, but almost identical to the last one I just did. And it doesn't matter if I give you foci here or I give you vertices here. This is only good for one thing. Who's important? The y's changed, so the y's are first. Now, what goes in this first parentheses? What goes in the second one? And here's where it's a little slightly different. That's not A and B totally. Somebody tell me why I should be changing that. Not treed, but rationalized. Yes, you knew something needed to be done to it because it's got a square root on top with the same number on bottom. Somebody rationalized our slope. We need to unrationalize anything in mathematics before we start trying to use the numbers. That's what we did back in trig, right? If we wanted to know what x and y were, we had to unrationalize it because you don't get the same math if you don't unrationalize it, okay? So I need to unrationalize this because 2 times 5 over 5 square roots of 5, the 5's will cancel, giving me 2 over the square root of 5. This is all about y's, and this is all about x's. Now, let's just talk about that for just a minute. If I had not unrationalized it, wouldn't I have squared this 5 and put 25 under the x's? But now I'm going to square this one. And I'm only going to have 5 under here. Up here, if I had squared this, if I had squared the 2 and got 4 and squared the square root and got 5, that would have been 20. But this is what I'm supposed to be squaring. I'm supposed to square the 2 and get 4, because that's what it was originally. A lot smaller numbers than the rationalized numbers would give me. So anytime it looks like it needs unrationalizing, you need to do that. As long as the square root doesn't have the same number on the bottom, like that square root of 3 over 1 didn't need that, because it was a 1 on the bottom, it wasn't a 3. All right. Any other questions there that look different? I've done one with vertices and foci, at least one of each one. One time when X started, one time when Y started. I've done 2 where I've given you asymptotes, and I can give vertices or focus over here, because when somebody gives you the asymptote, the only thing this is for is to see who changed, because that's the more important variable. There's nothing different from that on there, right?
On number 3, the asymptote, it says y minus 1 equals plus or minus 4 over 3x. Since it's just x, does that mean it's just 0?
Right. If they don't put a parentheses, that means x minus 0. All right, anybody else see anything different?
Number 1 on the independent practice. What if neither of them change?
Yeah,
Oh wait, yeah they do. My
one's
bad.
3
Sorry,
one's
sorry,
positive.
I said, yeah, they better have, I got a typo. All right, everybody agree? That this, okay, so I'm going to give you a few minutes to work on that, because I would like that packet taken up today so I can get it graded and back to you so you'll know what you missed. While you're doing that, I am going to start passing back some papers today that I have graded. And I'm going to pause this video because I want the people who are out to be able to watch what we've done today. Okay, so we found a typo on question number 2 on the independent practice. The points for the vertices are correct. That would be the correct point, right? Negative 1, 2 is the halfway between your vertices, because that's what our asymptote equation is telling us. But the foci are incorrect, so take out the foci, because I copied those down from question number 1 by mistake, and put this in for the asymptote line, and then you'll be able to work your question a little bit easier, because that's easier when you got asymptotes, right? All right, so that's what's wrong with number 2 on the independent practice.